Hello and welcome to a new video, and in this video we are going to make a simple plane controller mechanic thing, and it's going to be entirely within the physics engine, so no messing around with transforms or anything like that. Well, we're going to use transforms, but we're not going to be modifying the position of the transforms. We're going to let the physics do all the movement. So we'll get straight into it. The first thing we need to do, just for the sake of making things nice and simple to follow, is we're going to go into project settings, and I am using the old input manager system. I just haven't been able to bring myself to start learning the new one yet. So, and yes, I know it's very simple. It's literally a matter of me being lazy. It's not that it's difficult, I'm just lazy. So what we're going to do is we are going to change the horizontal one to the horizontal axis, to roll. And then we're going to change the vertical axis to pitch. And then we're going to just copy one of these. So I will copy pitch, doesn't really matter. And then we're going to add one more axis at the bottom here. If we just paste that property and then rename this one yaw, and we're just going to change the values that we use from down and up to Q and E. So basically that just gives us another axis that we control. I'm saying axis weird. That we control using the Q and E keys, exactly the same as the up and down and left and right, which are now pitch and roll. So we've got our plane here. The plane that I'm using is a free asset from the Unity asset store. I will drop a link in the description, obviously. And the first thing we need to do with the plane is set it up. So if we go up to our components for our plane, the first thing we're going to add is a rigid body. And then obviously we want to add a collider. So obviously if you were making a proper game, you wouldn't just stick a box collider on your plane. You go into a bit more detail. For the sake of building this controller, we don't need the plane to be meticulously rendered in the physics engine. We just need a mass representing the plane. So our box collider is just going to go from the bottom of the plane to the top of the plane and really just cover the central mass. So that's plenty for what we're doing. And because we're using the physics engine to control our plane, we need to set up the rigid body properly. And I'm treating a single mass unit as equivalent to a kilogram. So a little Googling suggests that a plane about this size would be roughly 400 kilograms. So that's what I'm going to set for my mass. And then we also want to set our drag and our angular drag to 1. And for now, just to get things going, we're going to turn gravity off. We will be turning gravity back on because we're going to try and use the physics engine as properly as possible within my limited abilities. But for now, we're just going to turn it off so we can get things up and running. So let's open up our scripts folder, create a script that we're just going to call plane controller. And there's going to be a lot of code all in one go here, but I'll do my best to take it slowly and explain everything as I go. To be honest, this isn't that complicated. People who've been following my channel will probably grasp this quite easily. So first off, we need some values. So we're going to start off with a public float, which we're going to call throttle increment. I'm guessing anyone who is interested in this video knows roughly how a plane works. I'm not saying you're all pilots, but like you probably played a flight simulator. But just in case anyone doesn't, you don't have an accelerator in the sense that a car does, where you just put your foot down and it goes. You have a throttle, and it's kind of like always on. So like if you give it half throttle, it is on half throttle until you move that lever again. So this throttle increment is going to be how much our throttle goes up or down when we're pressing the appropriate button. And then we're going to need a max throttle value, which these values that I'm setting as default, by the way, are just values that I've messed around with and found feel right for my little plane. But these are entirely changeable, and as you can see, the public values, they're going to be in the inspector. You can change them easily from within Unity. I'm just giving them default values that I know feel somewhere near right. So I'm just going to copy my little tooltip values in here. So as you can see from the tooltip, throttle increment is how much the throttle moves when we press the buttons. Max throttle is the maximum amount of throttle that we can have. And then responsiveness is like how twitchy the plane is. Like if we tilt it to the side, dip it forwards, backwards, how quickly does it do that? Tipping and dipping. So after that, we need some values that aren't visible in the inspector. These are the behind the scenes values. So throttle is the actual amount of throttle, and then roll, yaw, pitch, all these are self-explanatory. Well, actually, sorry, are they self-explanatory? Again, I don't know how much people watching this video know about planes. So I will pull up a picture in 1 second. So yeah, here's a nice little image I've just yoinked off Wikipedia. This shows the axis of rotation. So roll, pitch, and yaw is essentially the 3 different planes of rotation rotation that you can have. Pitch is kind of dipping forwards and backwards, or dipping forwards or tilting backwards. Rolling is exactly how it sounds, roll. And yaw, I think of as just turning. So it's just like flat turning, no dipping, no tilting. You're just turning left and right. So that's our main axis of rotation. And these values here are how we keep track of that. So the final value that we're going to add here is going to be a get value, and it's going to be called response modifier. And all this is going to do is it's going to return rb.mass. RB, by the way, we haven't, you know what, it's going to keep trying to autocorrect that, so let's just add that now. RB is rigid body. We need to get a reference to that. So it's going to return rb.mass divided by 10f. Again, this is just a value that I've found works, and then we're going to multiply that by responsiveness. So what this does is it takes the plane's mass into account when we're talking about like how the plane moves. So if we just had the same responsiveness value for a plane that weighs 1200 kilograms, then it's going to behave weirdly. So the higher the responsiveness value, the quicker the plane will turn and roll and pitch and yaw and everything, but factoring in the plane's mass. So in theory, you should be able to put any mass of plane in you want and then just set the responsiveness value independent of that. In theory. Okay, so that's it for our values. Now we need an awake, and all we're going to do in the awake for now is exactly what Visual Studio is suggesting there. We're just going to get the rigid body component, and then we can start writing some actual functions. So our first function we're going to call private void handle inputs, which is going to do exactly what it sounds like it's going to do. So easily enough, the first three values we get are roll, which is just going to equal roll input dot get axis roll. And this is why we renamed them. We could have kept them horizontal and vertical. It would have worked perfectly well. It's just this way the names match. And then I'm just going to copy that 2 more times. And then we want pitch and yaw. So that gets our rotational values. Then the next one is the throttle, which is a little bit more involved, but not particularly complicated. So we're going to say, so I'm going to use the space and control keys. Again, you would set them to whatever you want, and you would probably do it in a better way than me so that it could be rebound by the player in the game. But I'm just going to use the keys outright because this is more about showing you how the plane mechanic works rather than how to make a plane game. So I'm just going to say get key, keycode dot space. And if we are pressing keycode dot space, this is just get key. So this is anytime the space bar is down. Throttle plus equals throttle increment. Else if, not else false, else if, yeah. Get key, keycode dot left control, and then we just go the other way. Throttle minus equals throttle increment. Now the throttle is a percentage. So basically we have up here, we have our max throttle. So that's poorly named. That should be like max thrust or something. In fact, let's do that. Max thrust, because that's not a good name at all. Max throttle. That's very misleading. So our throttle is essentially a percentage of 0 to 100 of this number here of max thrust. So if throttle is at 100, we're getting 200 force in our engine thrust. If it's 0, we're getting 0. If it's 50, we're getting 100, etc. So we need to clamp this to make sure that we don't A, go into negative numbers, because that would cause the plane to behave very weirdly, or go past our maximum thrust, because if the plane has no maximum thrust, it'll just shoot off into space. So to do that, all I'm going to do is mathf.clamp throttle, and then just naught 100. And that's the end of that function. So we want our update next, and all this is going to do for now is just handle inputs. And then finally, well, not finally, but finally for now, we want a fixed update. So I believe I've said this quite a few times on this channel. Anytime you're working with physics, the actual physics needs to be done in fixed update. And this keeps things from getting jittery and weird. So we're going to add force, and this wants to be transform.forward. So it's transform.forward is forward to the plane. So vector3.forward would be an absolute forward in the game. Transform.forward is forward in relation to the plane. So that's telling us which way to go. And then we're multiplying that by max throttle, and then we're multiplying that by throttle. We're not multiplying it by max throttle because we changed it. Max thrust, and then we're multiplying that by throttle. So that gives us our forward force, like the force imparted by the engine, but modified by the throttle amount. And then the next three values are add torque. So for people who don't know, add force adds a force, like whichever direction you want, it will start pushing the rigid body in that direction. Add torque adds rotational force. So the first one is rotating around the up axis, and that's going to be times yaw, and then times response modifier. And then we'll just copy that because these are quite similar. So then after that, it is the right axis, and this is for pitch, and then the forward axis, and this is for roll. So we're back in Unity. Let's go to our plane and drag our plane controller script on here. As you can see, these values are already in place because I set them in the code. But again, if you were making a flight game that was flying a Boeing 747, these values would want to be a bit different, as would the ones in the rigid body. But if we press play now, we can see that our plane can fly. Not fly, sorry, tilt and move. And obviously this looks quite counterintuitive when it's, this doesn't look very intuitive when it's sat still. We can actually make it move forward, which makes it look a bit more like an actual plane. So one thing that I'm going to do next, as you can see, the plane just flew off into the distance there. So before we carry on, I'm just going to make a little quick camera controller. This is in no way important to this tutorial. So if you're not bothered about the camera controller, if you check the chapters down below, you should be able to just skip past the camera controller part. If you want to cheese this part just so that you can keep the camera with the plane, just drag the camera into the plane object so that it becomes a child of it, and then it will stay behind the plane at all times. I'm going to do something a little bit more advanced because I want the camera to sort of not 100% lock in step with the plane so that you can see some movement. But yeah, like I say, you don't need this part. But if you are still with me, create a script called camera controller, wait for Unity to finish faffing about. I'll just drag that onto the camera controller now before I forget. We'll open that. So what I'm going to do here is create a serialized field, and it's going to be an array of transforms, which we're just going to call POVs, and then again a serialized field, and this one is just going to be a float, and it's just going to be speed. And I think that speed is pretty self-explanatory. Speed is how quickly the camera will move to the position it should be in. So essentially in this script, all we're doing is we're saying to the camera, here's where I want you to be. Speed is how quickly it gets there. And what this does is it gives the camera a little bit of delay. When you just drop the camera into the object and make it a child, it's fine. It follows the object around, no problem, but it's locked perfectly in position with that object. So you can't see any movement in the object, and it makes it look weird. It looks like it's just like a picture stuck to the screen and the camera's flying around. Whereas if you let the camera follow along but have a little bit of delay, you can see the movement in the plane relative to the camera, and it just gives it more of a, I don't know, a sense of dynamicness, if that's a word. I write for a living, it's definitely not a word. And then we need some more values. So int index equals 1, vector 3, target. And obviously index is going to represent the current POV that we are looking at, and target is where we want the camera to be. So let's make an update. If input.get key, and this time it's get key down. We don't want this to be registered every single time the key is down. We only want it to be registered when the key is pressed. Keycode.alpha1. So this is saying if the number 1 key is pressed along the top of the keyboard, again, you would bind these however you want. Index equals 0. And then we're just going to copy that. I'm just going to add 4 in total, but you could add as well. I mean, in theory, I guess you could add 9 because there's only 9 keys, or 10 if you want to use the 0 key. But, or you could just have, you could cycle through them maybe with the mouse scroll wheel. It's entirely up to you. I'm just going to add 4 for demonstration purposes. So that sets the index of the POV array that we're looking at, and then we're just going to set the target to POV's index dot position. No, sorry, dot position. And then finally, in our fixed update, and I know the camera itself is not a physics object, but we are following a physics object, and if you try and follow the physics object in the normal update loop, what tends to happen is the physics will get updated sometimes before, sometimes after the camera gets updated, and then you get a horrible jitter. So if you update it in the physics update, at least it remains consistent. And here's a little comment to that effect. So we're going to say transform.position equals vector3.move towards, and then we're moving from transform.position to target, and then the amount, we're going to say time.delta time times speed. And then also we're going to say transform.forward is equal to POV's index.forward. Obviously with this one, you'd probably want to make this a smooth transition rather than just snapping it to the forward position as well. But like I said, this camera isn't crucial to this script, so I don't want to spend too long on it. So let's go back to Unity. Right, so we've got our camera script here. Speed, I'm going to set to 800. And then we need 4 items in our array. So if we go into our plane, now these do want to be childed to the plane. And the reason for that is that keeps them in a relative position to the plane. No matter what the plane's doing, they will be in that same offset relative position. So all we're going to do is create some empties. Just call up POV1, POV2, POV3, and POV9. I'm only kidding, it's 4. So POV1, I'm just going to stick there. And then POV2, we'll go a little bit further back and we'll move it up and we'll tilt it down a little bit. So it's sort of looking at the plane. POV3, we will have as kind of like a cockpit view, although it's not going to be a cockpit view because you can't see bugger all from this cockpit. So where we'll actually put it is just above the wing. Oh, let's stick it like here. We'll go with that. And then finally, just because it comes in handy later on in the video, POV4, I'm going to stick in front of the plane looking back. So let's just go up to the side a little bit and we'll spin it round so that it's facing the plane. So let's just go back to our camera script and drag these in and just give that a little test run. Okay, so our camera's moved to whatever position we had by default. Oh no, it didn't. It moved to the second one for some reason. Oh, because I've got it set to 1. So yeah, okay, so because in the script here I have this set to 1, it automatically defaults to the second POV position. And also, I haven't changed these. Well, that wouldn't have worked. Let's try that again. So this is the 2 position, this is the 1 position, this is the... Ooh, that's not good, but it's close enough. And then we have this. Let's just tilt that one a little bit more that way. And then this one will move up a little bit. So 1, 2, 3, that's better. And 4, yeah. Right, and now when we start moving, our camera will stay with the plane. So one thing I've just noticed while flying around with the plane there is that I have one of these the wrong way around. This should be minus transform forward, so essentially transform backwards. Right, so we've got our basics set up. The problem we have now is if we re-enable gravity on our plane and then press play, obviously it drops to the floor. Now we can start giving it some forward force and it'll start moving forwards, and we can give it all the force and it'll start moving quite fast. But we can't get off the ground. We can't, because gravity is pulling us down, and because essentially we're a box. You saw the collider was an actual box, but also we can't turn, we can't pitch, we can't yaw, any of that. So all we need is just a little bit of lift to get off the ground, and once we're off the ground, the physics handles the rest of it with the engine thrust. Like if I disabled the ground now, and I'll just re-enable it, you can see we are actually airborne now. But we just need to get off that ground. So it's quite simple to do that. All we need to do is apply some upward force. I've done very limited research. Like, I'm not an aerodynamics engineer or anything like that, or an aerospace or an aeroplane, whatever the hell the proper term for the geniuses that do this kind of thing are. My very limited research leads me to believe that for the sake of this simulation, all we need to do is simulate some upward force that is kind of proportional to how fast we are moving in terms of airspeed. Airspeed being slightly different to just pure speed, because if you're flying into a headwind, your airspeed would be higher. Even though you might still be doing 50 mile an hour, for example, your airspeed would be higher because the wind is coming towards you, so your relative speed to the air might be 80 miles an hour, even though the plane is only moving 50 mile an hour. So whenever the plane is more or less horizontal, and apparently this accounts whether it's the right way up or upside down, it will generate upward force as it's moving through the air at enough airspeed. So all we need to do is work out roughly what sort of speed we want our plane to be able to lift off the ground. Again, my little bit of research suggests that this plane would probably need to get up to about 90 to 100 kilometers an hour to take off. And then we just tweak the values until that's what happens. So in order to do that, and again, this isn't strictly necessary for this tutorial, but we're just going to make some little UI elements to show us our airspeed and things so we can make sure that our plane is taking off at the right time. So let's add a Text Mesh Pro doohickey, and we're just going to lock it to the bottom corner. We're not doing anything particularly fancy with this. Anchor it there. We don't need it to be too big. 24 is probably good. Make it bold. Let's have throttle. None of this really matters and in this part because we're going to be setting all these values in the actual code, but I just wanted to make sure everything fits. So we need to make it a little bit higher. Let's just go with 100. 200 should be, let's just go with 300 just to be safe. Okay, and we'll call that element HUD. So let us head back into our code. Actually, let's just save that. And we want to go to our plane controller, come up to the top here, and we need to get a reference to our text object. So first off, we need to add the TM Pro namespace. There's only one P in that. And then if we just come down here and we'll say serialized field, we don't need it to be public. Text Mesh Pro UGU, and we'll just call it HUD. And then if we just go somewhere down here, private void update HUD. And then in here, all we're going to say is hood.text equals throttle plus throttle dot. Now we're going to say to string, and we're going to put this modifier F0. And the reason we're doing that is because the throttle value is a float. And if you just take a float and put it to string, you get like 4 or 6 decimal values. And obviously we don't want that. So this F tells us how many decimal values we want. So in this case, 0. We don't really need to know that we're doing 98.356% of throttle. 98% will be fine. And then finally, we'll stick a little percent on the end. And then we are also going to stick a \n on the end, and that tells the text element that we want a new line. Because then we're going to say plus equals. This could all be on one line. I'm just breaking it into multiple lines because it's easier to read, basically. Airspeed plus rb.velocity.magnitude. So this, oh, sorry, I'm missing a quotation mark. So this is essentially the speed that our rigid body is moving at in unity units. And then we times that by 3.6 to convert those unity units into kilometers per hour. And bearing in mind that this works because I'm treating each unity unit as a meter. It would, if you wanted miles, it would be different. Or if you were treating each unit as 10 meters or a centimeter for some reason, you would need to change this number. And then once again to string F0. And then this time we plus kilometers per hour. And once again, we need our \n. And then finally, hood.text plus equals altitude. We don't need this one. I just, because it's so easy to implement, I figured why not? Well, I say easy, but apparently I can't spell altitude. Transform.position.y.toString, and again, F0. And then just up here in update, we're just going to say update hood. So if we go back to Unity and we need to drag our hood object in there and give that a spin, you can see that we have our throttle values. And if I were to turn the gravity off so that we can fly, we get our altitude as well. And altitude obviously is easy because I'm treating unity units as a meter. So it's literally whatever the Y value is, that's the altitude above quote sea level or 0. So now we know that, we can start looking at our uplift force so that we can get off the ground. So back to our code, and we want to go up to the top here, and we want to add a new value, which is going to be called public float lift. And again, I have a value that I found worked, so I'm just going to drop that in there as a default. But once again, you would tweak this to suit craft. Like my Googling suggested that this plane needed to get up to about 95 kilometers per hour to get off the ground. A Boeing 747 would need to do, I think it was a 200 kilometers, I want to say. Anyway, it's not important. It was more. It was more than this. That's the takeaway from this. It was more. And then nice and simple, this one, we just want to go down to our force area, our fixed update where we're adding forces, and we're going to say rigid body add force, and the force is vector3.up this time. So this is universally up, no matter which way we're facing, the force is pushing us upwards. Again, strictly speaking, this wouldn't be true all of the time. As I said before, it applies when the plane is sort of horizontal, when it's this way around. I'm not a aerodynamics engineer, but I don't think it would apply if it was like, you know, this. But I'm not making Microsoft Flight Simulator here. So vector3.up times rb.velocity.magnitude times lift. And that is all we need to do to make it so we can get off the ground. So because the lift is, how do we say this? Because the lift applies on the plane regardless of whether we're pitching up, down, left, right or anything, we should start to take off at the speed that this number will give us, which should be around 100 kilometers, without me pressing any sort of controls other than the accelerator throttle. Yeah, you can see we started to leave the ground a little bit after 100 kilometers per hour. And then I can start pitching upwards, I can turn, I can roll, I can fly into the sky and crash, make my camera go all weird. And yeah, that is pretty much it. There's not really anything to add to that. I mean, like I say, there's things you could do, like obviously flying upside down. Apparently the problem isn't so much the wings and everything, that's all fine. The problem is the engines. The engines aren't built to fly upside down. Flying straight up, same problem. You know, there's all sorts of like tweaks. Like this video could easily be 50 hours long if we tried to make it anything close to like a super realistic flight simulator. Maybe think of this as more of a Grand Theft Auto level flight simulator. But the good thing about this is that all of the controls are handled by the physics engine. So you can quite easily just tweak all your rigid body values, the values in this plane controller script, and get it to behave how you wanted. And then just as, so that is basically the plane controller. I'm going to do a little bit extra. You're welcome to stick around for that if you want. But if you just wanted to know how to make the plane controller work, the video is essentially finished. So the little bit extra I'm going to do is we're going to go into our plane controller script and we're going to add another transform, and then down in update, and because this isn't a physics object, so we don't need this to be in fixed update, we're going to say propeller dot rotate vector3 dot right times throttle. So if we go back into Unity now, and in our plane we find the propeller model, so I'm just going to click on it to save time. It's called box 012. Drag that in there, and then if we press play, switch to our front view for a better look, we have a spinning propeller. And let's not stop there. We may as well give it some sound as well. So we're just going to add an audio source. I have already pulled an audio from freesounds.org. This is just a loop of a plane engine. Technically speaking, if there's any plane enthusiasts out there, this is a double prop engine sound. So I apologize that this is going on a single prop plane, but come on now. So we want it to play on awake and we want it to loop. And then if we go back to our code, we need a reference to that. So I'm just going to drop that below rigid body here. Audio source engine sound. And then nice and simple, once again, all we're going to do is in our update, we're just going to say engine sound dot volume equals throttle times 0.01f. So what's happening here is, like, you need to understand that this only works because throttle is 0 to 100. If throttle was 0 to 200, 0 to 135, something like that, this would not work properly. The audio source volume control is 0 to 1. 0, 1. So basically by multiplying 100 by 0.01, I make it, rather than 0 to 100, I make it 0 to 1. So when the throttle is 100%, the engine is at full bore, then the volume will be at full volume. So let's just make sure all this works. We don't need to drag anything in. We've already done our audio clip. Let's give it a go. I mean, it's not the most accurate engine sound, but it works. Ooh, prop looks weird when you've got the camera right in the cockpit view. And that is our script. So there is a bit of a weird bug with my camera script where it keeps every now and again rubber banding back. That is just with the camera script, and like I just threw that together to give us something nicer to look at. Like, let's not stress too much about that. Yeah, I like that. So that is it for this video. All that remains to do now is to thank all my amazing Patreons, who are, as always, greatly appreciated, and especially with the recent dry spell that's happened, the people that are still supporting me, I very much appreciate it. And of course, special thanks go to the Sugar Daddy / Mummy tier Patreons, who are Dave Maldine, Reg Reed, Gabriel White, Aaron Clark, Mr. Drunken Dragon, and Andrew Hansen. You guys are particularly amazing. For those of you who don't want to or don't have the means to throw anything at the Patreon, just know that you are also appreciated. Just like, share, send a video to a friend, comment on the videos, all that stuff also helps. That's it for this video, so hope you enjoyed it, hope this video was useful, hope you come back for the next one. Bye bye.